Hello, assalamu alaikum. I hope you're doing well and in the best of your health. And welcome here in another episode of the Generative AI series. In the last session, we explored the generative AI powered by transformers, understanding how a model like GPT can generate a human like text. And these large language models are extremely powerful for a variety of tasks, from let's say creative writing to answering questions, and they achieve this by leveraging patterns learned from a vast amount of training data. So in today's session, we will try to explore something new that will deal with those large language models to make them more powerful. So we will, let's say, we will have a small part of theory, and we will move to our collab to have a hand-on practice. So just like before diving into the session, just let me give you a small recap about the large language models for those who did not attend previous sessions. So LLMs, or large language models, are advanced neural network, typically based on transformer architecture, that are designed to understand and generate human-like text. So those models are trained on a vast data set containing text. Those texts are, of course, from a variety of sources. That's what enable them to perform various language tasks. Okay, so today, inshallah, our collab will be about how to chat with your data using RAGs and LangChains. So here, why we move to those RAG and LangChain? Because the large language models are not enough. Yes, they are powerful tools. They help a lot. They are generating a human-like text, but they are not really enough alone. Okay, so they really do have, let's say, they are capable of generating a very high fluent context, but they do have some limitation, especially when it came to a real-time factual accuracy. Let's say if you are trying to retrieve data from events that happened recently, so maybe the large language model or like GPTs are not able to do those tasks or to do those generation. So here the limitation particularly came when it came to the outdated knowledge. So once we train a model, large language models cannot access information beyond their training cutoff. This means that they lack access to recent information or recent knowledge. Okay, so if we trained a large language model on specific data, so it can only generate text or data from the data that was trained with it. Okay, and also we have the hallucinations, where a large language model can sometimes generate answers that seems to be not correct, incorrect. Okay, since they don't look up data, the response are let's say from the trained data set. So that's why sometimes they generate those incorrect data. And also we can add the lack of context. So the large language models sometimes struggle when they need to provide a highly specific or personalized information unless we extract the data in their, let's say, in their training corpus. And also we have the memory limitation. Let's say when we need to chat with a model, so that they need to have a memory for some previous conversations. Okay, so those challenges here highlight the need for a more grounded approach that can help those large language models to do their job or to do the task effectively. And today we will see how what we call it the LangChain help with it, which is, let's say, it's a framework that designed to help or to work with the large language models. Fine. So first of all, we can start with the retrieval augmented generation, or RAGs. So RAGs here, it's a technology that enhances the capabilities of the large language model by combining them with an external retriever system. So instead of relying on a pre-trained data set, the model here tried to train or to, let's say, to fetch relevant information from a knowledge based on let's say, from some documents that are stored, let's say, or let's say retriever from different sources. Okay, so for example, imagine like you're trying to ask the large language model on ChatGPT, for example, what is the most recent update about the climate change in Africa or in Europe. So here, a regular large language model might not know the answer if it was trained before the most recent events. Okay, so for example, if you go right now to the ChatGPT and you type a question asking about, let's say, when was the last time Israel bombed the south of Lebanon, maybe it will not be updated or will not have data for those information because those events are recent. Okay, however, when we talk about a RAG system, so the model here would first retrieve the latest article or reports on a specific topic, Israel and, let's say, wars, climate changes, and any other topics from an external database or dataset. And then it generates a response based on the up-to-date information. Okay, so I'm sure that you already tried a query or prompt on ChatGPT and told you that the last information that they do have or what's trained on it was in 2021. So the ChatGPT don't have access to some recent information. So here with RAG, it will be able to have some updated information. So here, if we can sum up, the RAG here bridge the gap between the static language model and dynamic real-world or real-time information. So this will allow for more informed and the context-aware response that, let's say, stay relevant to the new knowledge or the new developments. Okay, so I hope that you got a general idea of the RAG. And I hope that it's clear for you why we should use RAG. So we said, yes, the large language model such as GPT and BART are powerful, but they do have limitation. So here, main of those, the limitations is the hallucinations and the memory constraints. So when we talk about sometimes the large language model generates those incorrect information just because the data was trained on some old or let's say, yes, some old data sets. For example, if you ask the large language model who won the FIFA World Cup in 2020, the last World Cup was I think in 2022. So here the model will say that that it was trained till 2021. So the ChatGPT don't have information about what's happened after 2021. Okay, so here maybe it may guess an answer for you, or just like tell you that based on his information, they don't have information about future events after 2021. And also we talk about the memory constraint. So we said that large language model only know what was in their training data and can't remember or update information after their training is completed. So they are fixed model. Okay, so this is the limitation. They are a fixed model. They don't have, or let's say, yes, they don't have access to some real-time knowledge. So here, RAGs came to fix this issue by grounded in real data, by incorporating or retrieve step. Let's say RAG allows the model to consult the real world data before generating a response. So here it's making it less hallucination, or let's say give some at least maybe some correct or some relevant answers. And also RAG, they are dynamic. They do have the dynamic knowledge. It's enable the model to access and integrate some up-to-date information addressing their memory limitation. So so here, when we can use RAG, let's say we have the RAG to support a chatbot of a company. So here we may need to use RAG to retrieve relevant information from a document to build a chat for a specific company. So if you go back to ChatGPT and ask some private information about your company, maybe ChatGPT won't be able to help you or to give you those answers. But you want to build a chatbot in your website. So here you should train your model using RAGs and adding some documents. Those documents, the RAG or this model will try to retrieve information from your private company documents or private documents of your company. Okay, and like that, it will be able to chat, to answer any question from users, as long as we give it access to those private data that we do have. Okay, so this is in general about RAG. Small recap, or just let's say how RAGs really works. Okay, we already mentioned that, but yeah, RAGs, first of all, it will retrieve the data and then generate. So when we say it's a retriever, that means it fetch relevant document from a corpus based on their user's query. For example, any query, you just like type it. The RAG here try to fetch all relevant information or the relevant information from different resources in the internet or documents, or let's say any resources, just like to answer your query. And then after fetching those relevant documents, it will generate data. So here the generator use what was retrieved. Okay, so here the generator use the retriever, use the retrieved document to generate more accurate and contextual rich responses. And here, whenever we talk about RAGs, there is something linked to it, which is the LangChain. So before diving into LangChain, let me check if there are any questions here. Okay, so no questions so far. So please, if you have any question, don't hesitate to ask. Yes, so here, as I mentioned, whenever we talk about the RAGs, it's linked automatically with those LangChain. So LangChain is a powerful framework designed to simplify the process of building applications that use the large language model by offering some tools. Okay, those tools are used for chaining language model, because the LangChain here allows developer to combine multiple large language model operation in a structure of pipeline or a chain. That's why it's called LangChain. Okay, it's combine multiple language models, which is chaining together. Okay, so this helps to create a more sophisticated workflow. Okay, so we have also the LangChain. Also, it's I mean, the tool is offered for the document retrieval. It can help to retrieve the relevant document from various sources, including APIs, databases, external knowledge, let's say any other data sets or databases, and then pass them into the large language for processing. And this make it particularly useful for RAGs. Okay, so those LangChain here will be useful for all RAGs applications. And also we have the memory management. So LangChain here also provide the memory capabilities, allowing the system to remember and track information through conversational or let's say from old conversations. So here, which is essential for building those chatbots and conversational agents. Okay, so this let's say just like it's have a memory for all the dialogues that were done before. Okay, so here if we talk about let's say suppose you're building a custom support chatbot I mean, with those LangChain here. So you can create a chain where the model can retrieve relevant documents, summarize the documents, and then combine the retrieved information with the let's say with the previous part of conversation to generate an accurate responses. Okay, so that's why here this LangChain is a framework When we say framework, it's a helper. That means it will help to simplify the process of generating those answers. And the key components for a RAG system are, let's say, document store, retrieve, a large language model, and a chaining component. Okay, so here, LangChain here is particularly effective for RAG systems because it essentially handles both the retrieve of relevant documents and the generation of responses. And this is the main task of the RAG system. Okay, and of course, this will ensure a seamless integration between those two processes. So if they do have the same thing or they help each other, so it will be, let's say, they will help each other, or let's say one complete the other. So here, if we talk about LangChain can query what we call it a vector databases to fetch those relevant documents based on the user query. So based on the prompt or the query that the user just like submitted, it can query all the vector database to fetch relevant information. So it supports multiple retrieval method. So we have a lot of retriever method. We will do one of them in the practical part in few minutes. And let's say here it supports, let's say, dense vector retriever and many other retrieval methods, and integrate well with all the databases. Okay, so for example, if a user asks what is the latest advance in quantum computing, for example, so here LangChain would query a vector database of all the academic papers, and it would retrieve the most relevant section or document related to the user's queries, which is about the quantum computing. Okay, and also it has the thing of document processing. So after retrieving the relevant documents, LangChain here start to process them by breaking them into smaller parts. Okay, we will see that in the collapse also. So those smaller parts, let's say, they are more manageable, and we can let's say filter them to the let's say relevant part, irrelevant part, and so on. And this of course ensure that the language model receive the most correct or information for generate a response. Okay, so here if a LangChain can be used to extract a key insight from a lengthy document, this will ensure only relevant information is passed to the language model. And also we talk about the chaining components here. So the chaining operation here, let's say, is the ability to chain multiple operations together. So in the RAG scenario, this allows to combine various steps, such as querying a vector database, retrieving relevant documents, processing those documents, generating response, and so on. So this ability is to chain steps to reduce the complexity and to improve the quality of the generated responses. Okay. So just like remember the workflow. So we have retrieve the information or the relevant documents, let's say filter or process those documents here, summarize them, and then generate the relevant output. And let's say generating, the last part is generating or response generation. So here's once the LangChain retrieve and process all the documents, it's passed to the generator of large language model and create an informed, rich response for your query. Okay, so those are the main key components of the RAG system. So now let's move to our collab. Okay, so here we have a question. What is the point of combining multiple large language models? So let's say there are a lot of large language models. and every language model with their capabilities and speciality. So let's say, what if I prefer to use one language model to interpret some user queries, and let's say I want the result to be from another language model. So that's why I just like try to combine multiple language model, because each language model have its capability, and let's say one language model is powerful in doing X, the other one is powerful in doing Y, and so on. So we can combine them to get the wanted or the relevant output or results. Okay, I hope it's clear for you, Mohammed. So just like to take the feature that I like from each language model. Okay, thank you. So here in this, we will try to build a very simple chatbot using Grag, of course, using the framework, with the LangChain, and also using the Hugging Face. So here to run this this lab, you should have a Hugging Face token access. Okay, just let me copy it from somewhere else. From okay, where is it? Just give me a second. Fine. So let's compile this. So here I would just like try to link my collab here with my Hugging Face account. Token API main, and then I should install some important libraries that we should that I may need. We have this FISS GPU. This will help me for the vector database. Okay, let's think about it as a database. We have the LangChain community, the sentence transformer, PyPDF and LangChain. So this PyPDF, because I will try to show you how we can extract information from PDFs and so on. So also always think about the example of you're having some private documents for your company, and you want to build a chatbot. So models like GPT and also the other models don't have access to the private information of your company, but the chatbot should answer let's say queries based on the company information. So here we can give the model some PDFs or some links related to the company, and like that we can generate a model that can answer those questions here. Okay, so those are the main libraries that we need. Let's import everything here. Actually, I didn't use all those. It's zoomed a little bit. It's zoomed a lot to a point I cannot manage it. So here, just like this is a bad practice, but before writing code, I just like import any library that seems to be used. So yes, of course, I didn't use all those libraries here, but I just like import them anyway. Fine. So here, let's define our large language model. Here, as I mentioned, we will be using the Hugging Face. Okay, so our large language model is from Hugging Face. So here we have the repo ID here. This is specific to the repository ID of the model. So let's say you want to use this model or any other model. So in this case, here we're pointing to this model in here. Okay. And of course, this model is maintained by the Hugging Face. We have here the task, which is the text generation. So the task you're using the model for here is to set to generate some texts here, meaning that the model expects to generate text based on the inputs. Okay, so when I specify the text here, you will have an idea that it will generate some text, texts. Yes, fine. And here we have the model knowledge. Let's talk about how the dictionary of model specific arguments to control the behavior of this text generation. Let's say we're having what is the max new tokens, the top K. The top K is the limit sampling tool. Let's say here we have 40, so the top refers to one of the most probable next token during the text generations. We have the temperature. So temperature here, I kind of control the randomness. We have the top P, which is also known as the top P sampling. So it's used for the sampling here. We have the presence penalty, frequency penalty, repetition penalties, and those penalties here appears of the, let's say, the new token that have already appeared in the generated text here. Fine, so those are some argument or some parameters. Of course, there are more, and you can remove some of them, let's say, to have a good API, just like I entered here when it was asked for. Okay, fine. So for those who don't have API and Hugging Face API token, simply refer to the Hugging Face platform and generate an API token. You can use this up. Fine. So as I mentioned, let me here. So here I defined and specified for my model. Now let's move to the chatbot. Here, as I mentioned, we use generally the RAG to have access to new information or some new private data. Okay, so the clear example is to have some data about your company private documents. So those documents could be either PDFs that are not public online. So even that RAGs have access to all the information and can retrieve relevant data, but as long as your data is not public, it cannot generate some data from it. Okay, but I want those data will be for my, let's say the answer will be based on, let's say, based on the law of my company or something related to my company. So here I can load some PDFs and RAG can try to retrieve the answer or the query from those PDFs here. For me, I don't have, let's say, I just like, since I tried if the ChatGPT can answer who won the last World Cup, which was in 2023 or 2022, so it's after 2021. So ChatGPT is not able to answer this question. So we try to load here a random PDF about FIFA, and then we'll try to ask the model to extract the information from those documents in here. Okay, so to do that, we have here those web-based loader is to load some URLs. For example, links from the official website of FIFA World Cup, since the GPT models or the Hugging Face model, for example, that I'm using, don't have access to it. So I just like give it a link to those information, just like as a helper to help from where it can retrieve the data. And then we're storing our data here in this old docs, and then we can also load some PDF. The reason why I did those two things, just like to give you an idea that we can help the RAG from where it can retrieve data. Okay, so either by providing some PDFs or providing some links, some databases, some sheets, any data, you can pass it here. And of course, you use your Python code to retrieve and load your data. So this is the first part, is to load data from specific data sources. And then, as I said, it will split it or sample it to some smaller parts so that it can be processed, so that it can process it easily. Okay, so here we're splitting both the URLs and the document or the PDF documents. Okay, we have here some parameters such as this chunk size and chunks overlap. Those are just like parameters that are commonly used here in the natural language processing NLP task. So particularly when working with a large text or databases. So here when we talk about a website link or something, or the huge PDF, so here we're dealing with a very large text. So it's let's say it's a good approach to split it into parts, or to break it down of what each parameters here, let's say, to break it down on simple or smaller parts. Okay, so here this chunk size, this parameter defines the maximum number of tokens that each chunk of text can contain. So here we have in this case 1,000, 500. Okay, those are the hyperparameters that you can change later to have a better results, of course. And we have here the chunk overlap. It just like this. This parameter specifies the number of tokens that should overlap between the chunks. For example, if I have let's say if I have a very long text, and here I have chunk size equal to 500. So the first chunk here will be from 1 to 500. So this is logic. And then here I'm specifying that the overlap should be 50. So the second chunk here will overlap the last 50. So it will not start from 500. Just please imagine with me the scenario. The first part is from 1 to 500. Then I said the overlap is 50. So the second chunk will overlap the last 50. So it will be starting from 451 or 50 to let's say after 500, which is 950. Okay, so some data are repeated from the two chunks there. I don't know if it's clear, this idea or not, but it does like to overlap some information here. And of course, this is just like to improve the contextual understanding. So help maintain the context. And let's say it's how the better the model will perform, because dealing with a smaller and well-defined chunks allow the model to make a better prediction or generate better outputs here, and also to make it scalable to handle large text in smaller segments here. So those are the second part of splitting our data. And then here I just like combine the data of my data set to have it in one variable, which is all texts, or it should be all resources here. And then I create our embedding. So if you attend the natural language processing session, you will absolutely know what is the embedding. So any text data, we should embed it before performing it. And then here we're having this DB, which is let's say database to store our things, and here we're having our retriever to retrieve from our database. Fine. So first of all, we load the data, we split it, and we embed it. Okay, so those are the parts. And next we move to our template. So what is here the template? Maybe you can notice before. But if you write a good prompt, you will get a good answer. Okay, so here we should have a template of what the model should do. So here maybe you can write wherever you want to guide your model. So saying, for example, based only on the following context, provide a consistent answer to the question. Don't just like answer your question. It's just like you're talking with your ChatGPT. I don't know if you did that before or not, because sometimes ChatGPT just like give you some random information, not correct information, and here you start teaching your ChatGPT. Don't tell me this. Try to be smaller. Try to give in few lines the answers and so on. So here we're just like saying and those restriction or those condition to my models, and we're having the context, which is the data that it will retrieve, and then it will have the question and the answers, of course. Okay, so so this is about the template, and then we added to a library called the chat prompt template that will help for for creating our chatbot. Okay, so we're feeding it with this template, so it has all the conditions and all the restrictions that it should do there. So this one, it was executed. Let's execute this one as well. Fine, and then we feed the chain with the prompt, with the model that we do have, let's say with the retriever, every parameter that we prepared, and then we ask the model to take the query that the user will provide. Okay, so it will run the query and then it will provide an answer. So here I ask it because it's used to let's say output all those the context and the question and the answer. So I try to reduce the output to be the answer and the question only. Okay, so if I remove this one, it will have a very long text that contains all it's retrieved. Fine. So here are the links or the URLs that I want my my RAGs to maybe work to retrieve data from it. I mean, it's added to its knowledge to explore those files as well. And then we can simply pass our question, who won the last World Cup? Or you can ask wherever you want, any question that you want. And then we call our we call our function here, chatbot, chat with RAG. And this is here the answer. So it's writing here the question, and then the answer here saying that it's Argentina, but at the same time it say that we cannot say because here it was the last World Cup. So in case they don't know which year we're here, they say we cannot, we're not certain for who will win the next World Cup. So just like it takes a lot of time, that's why I avoid run it again. So of course you can here change the you can change your question and check your model. Fine. So this is about the how to add RAGs to language models and how it will have access to some updated information and new data, and of course some extra data from your PDFs or some from your private data sets. Okay. So if you have a question, if you have any question, please don't hesitate. I think we do have questions here. So please, can we have the presentation and the collab notebook? Yes, of course, I will share with you the collab notebooks. And the presentation, it's not really organized, so maybe I can organize it because it's contain all the previous sessions. So maybe I can just like cut today's session and maybe you can find it in the comment section of the session. Fine, or in the description. Here we have another question talking about the repo ID of the pre-trained model. Yes, this is a repository ID of the pre-trained model. I think you're talking about this Hugging Face repo ID. Yes, it's here. I think you're talking about this. So this is the ID of the repository of the model. Okay, just like to know which model it's here. If you want to use another model, for example, smaller data set or something else, so you can just like change here your model. And of course, it's from the Hugging Face in here. And what else? How overlap does not cause redundancy, how it's helped to maintain the context. So of course those it may cause the redundancy, but those are just like the hyperparameters. Those hyperparameters, of course we can change them if we felt that the model is not acting correctly, but at the same time they are helping to improve the contextual understanding of the model. Okay, so here by just like overlapping only 50 or 25 or 30, it won't cause the huge problem. In contrast, it will help you to improve, or let's say to give a better performance to your model. Okay, so if you've noticed that your model is not generating good answers, or it generating some let's say just sometimes the model just generate, don't give you a relevant information. So here, of course, you can change those hyperparameters in your code. Actually, yes, the model needs to fine tune it. It's not using only our PDFs, but it's use the PDFs there, because here we're already let's say here, based on your question, why we are calling this this large language model. So it will use all the knowledge just like to provide you a correct answer. Okay, so just like it's doing the same job as GPT in ChatGPT, but let's say here with some extra information, some newer information and knowledge. Okay. Okay, thank you about the hyperparameters. Okay, so any other question? I may share here with you the collab. You can of course use other links, other queries. You can just like I highly recommend that you play with this collab until you will get a great and a correct chatbot that give you only correct answer and don't give you just like sometimes it just like give you some bullshit answers. So here just like try to work on your code and to make it give you only the correct answers. So here is the link. I may share it with everyone. And for the presentation, as I mentioned, just let me share it here. Yes, for the presentation, as I mentioned, it's very long presentation that contains all my sessions since 2021. Okay, so I use the same slide. So it may be, I will cut it into a smaller presentation containing only this chat with your data and add it to the description of the today's sessions. So any other question, guys? Okay, fine. So if you don't have a question, thank you so much for attending here. Thank you for participating and asking your question. See you in another episode, inshallah. Bye-bye.